Okay, objective 6, we're looking at writing rational equations. A couple of steps here. First of all, it does need to be an equation, so we do need either a y equals or an f of x equals at the front. Okay, the first thing you're going to do is take care of any vertical asymptotes or holes in your graph. Okay, if you notice that you have a vertical asymptote, then whatever that number is, wherever your asymptote is, you're going to put an x minus that number in the denominator. If you have a hole, whatever that number is, you're going to put x minus that number in both the numerator and the denominator, which will create a removable discontinuity, which is what a hole is. Okay, next you're going to take care of your x-intercepts. Any x-intercepts, whatever that number is, you're going to put x minus that number in the numerator. The last couple of things you have to always check are, first we need to look to see if you're a horizontal asymptote. If there is one. If we have no horizontal asymptote, that tells us we're top heavy, and so we should see our equation being top heavy. If we see a horizontal asymptote of 0, then that tells us we're bottom heavy. So again, we should look at our equation and see that we are bottom heavy. Or if we notice there is a horizontal asymptote, then we need to make sure that we are equal heavy, top and bottom, and that our coefficient does equal that horizontal asymptote. If it doesn't, then we're going to insert an additional coefficient to force that horizontal asymptote to be what it should be. You also want to double check your y-intercept, which means plugging in, so plug in x equals 0 to double check that my y-intercept does in fact work. And then making sure that if you see that you have a slant asymptote in your graph, double check before you kind of box in your final answer that your numerator is in fact 1 degree higher than your denominator. And again, it should be taken care of by now, but it's a good thing to double check. Okay, so here we go. Our equation, we have y equals or f of x equals. First things first, taking care of holes and vertical asymptotes. In this case, I have a vertical asymptote at -2. So I'm going to put x minus -2, or x plus 2, that's what x minus -2 is, in the denominator. Okay, we have a hole at -1, so I'm going to put x minus -1, or x plus 1, in both the numerator and the denominator. And then we've got an x-intercept in this case, an x-intercept at -3. So that's up next, so taking care of our x-intercept. So one x-intercept at -3, so I'm putting x minus -3, or x plus 3, in the numerator. Okay, double checking our horizontal asymptote. I do have a horizontal asymptote in this one. It's at 1, so I should see that I'm equal heavy, which I am. And then double checking our coefficients to see if I need to insert an additional one. My coefficient here is 1 times 1 over 1 times 1, so my horizontal asymptote is currently 1. It should be 1, so I'm good to go. Finally, double checking your y-intercept. When I plug in 0 into my x, I should get 3/2. That's what my y-intercept is. If I plug in 0 to my function here, I get 1 times 3, which is 3, over 2 times 1, which is 2, which is 3/2. And so that's my equation. Okay, doing another one here. Number 2. Okay, we have either y equals or f of x equals, whichever one you prefer. Vertical asymptotes. Vertical asymptotes first here. So we're on this step. Vertical asymptotes and holes, I should say. Okay, I do have 2 vertical asymptotes in this case. My first vertical asymptote is at -2. So x minus -2, or x plus 2, is going to go in the denominator. Just like it says up here for your vertical asymptotes. It goes in the denominator. I have another vertical asymptote at 1, so x minus 1 is also going to go in the denominator. I have no holes, so I'm done with that step. Next up, we have take care of any x-intercepts. Right? Those will go in the numerator. In this case, my x-intercepts are -1 and 3/2. So -1, we are doing x minus -1, which is x plus 1. And then x minus 3/2, remembering from last unit, we talked about how to turn this into a factor without this denominator. This 2 would pop to the front. So this would be 2x minus 3. Okay. Next up, horizontal asymptote. I do have a horizontal asymptote for this one. It is -1. Taking a look at my function, I am equal heavy, but what throws me off a little bit is while I am equal heavy, currently my horizontal asymptote is 1 times 2 over 1 times 1, which is 2. And I want my horizontal asymptote to be -1. Okay, so I need to manipulate this. I need to add some coefficients in here. If I have 2, so checking my horizontal asymptote, if I have 2 and I want it to be -1, what do I need to multiply by? Well, I need to multiply by -1/2 to give me that -1 that I want. So this -1/2 needs to be in my function. Oh, and I almost forgot, checking y-intercept. So plugging 0 into our x's, we'd have -1 times 1 times -3, which is 3, over 2 times -1, which is -4. 3 over -4 is the -3/4 that I see my y-intercept should be. So I know I'm done. Okay. Okay, at some point, either on this one or one of the next two, I would start pausing the videos, giving them a shot. Honestly, I'd recommend doing it on this one already. Pause the video, try number 3, get as far as you can, and then restart the video either when you have an answer or are stuck. Do the same thing then on 4 and the same thing then on 5. That way you are practicing these problems on your own and getting that gauge of what you do or do not know and coming in and asking questions as needed. Okay, so pause the video if you're going to do so. Okay, number 3, we have y equals. My vertical asymptote in this case is the y-axis. And so we know we have a 0, x minus 0, or x plus 0, or just x in the denominator. Okay. No holes, so we're good to go there. X-intercept, I do have an x-intercept at 1 here, so I'm going to put x minus 1 into my numerator. Okay, now, some people might have already caught something at this point, but for those who didn't, okay, when you get to the next step, which is to take, or to check if you have a horizontal asymptote, we have no horizontal asymptote here, which means I should be top heavy. And currently I'm not. Currently I'm equal heavy. I have a horizontal asymptote of 1. So somehow I'm in some way, shape, or form, I'm missing a power up top there. Okay, that power that you're missing comes from this x-intercept. Do you see how we have a bounce here? That means we know something about this guy's multiplicity. It's 2. Okay, if you find yourself missing a power, it means that you need to add some power to your function here. So in this case, it means adding a power to my x minus 1. Now we have no horizontal asymptote. The last thing we need to check is our y-intercept. Well, we have no y-intercept, so there's nothing to check. And so this is my answer. You also might spot check the slant asymptote. Since I have a slant asymptote, I should have a numerator with a degree 1 higher than my denominator, which I do. My numerator is 2 as a degree. My denominator is only 1. Okay, number 4. Go ahead and pause the video if you're going to do so. Okay, number 4, we have either our y equals or our f of x equals. Vertical asymptotes. I have one vertical asymptote out here at -1. So this is x plus 1 or x minus -1. I have a second vertical asymptote at 3. So we have an x minus 3. No holes, so I'm good to go there. X-intercepts. I have an x-intercept at 1 here. And so this is x minus 1. Horizontal asymptotes. Well, I have no horizontal asymptote, which means I should be top heavy, and I am definitely not top heavy right now. I have a degree of 1 on top and a degree of 2 on bottom, which means technically speaking I'm bottom heavy. This function that I've written here would show a horizontal asymptote at 0, which is not what my graph shows. Okay, so somehow we're missing a couple of powers up top. Okay, There's two ways you could figure out what this is. The first is recognizing that because 1 is still a pass-through, we know we don't have an even multiplicity. It means we have an odd multiplicity. And so maybe with that you already know that this x minus 1 would be cubed. Or maybe it's the fact that you look and you're like, wait, I have a slant asymptote. My slant asymptote tells me my numerator should have a degree 1 higher than my denominator. Well, since my denominator is currently 2, that means my numerator should have a degree of 3. It's the only way I'd get a slant asymptote. Okay, either of those two thought processes work. Finally, we are checking our y-intercept. My y-intercept here is negative 1/3. Sorry, this is negative 1/3 printed, kind of funny. But negative 1/3 is my y-intercept. So when I plug in 0 to my x, I should get negative 1/3. If I plug 0 in here, I get negative 1 over 1 times negative 3, which is positive 1/3. I want it to be negative 1/3, so I need to multiply by a negative. Okay? Last one. Pause the video if you're going to do so. Okay, number 5, we are looking at either y equals or f of x equals. Vertical asymptotes. I have a vertical asymptote at 1. So I should have an x minus 1 in the denominator. No holes, so I'm good to go there. I have 2 x-intercepts, 1 at negative 1, 1 at negative 2. So we have our x minus negative 1, x minus negative 2. Horizontal asymptotes. I do have a horizontal asymptote in this one, which means, first of all, I should be equal heavy. Well, I'm not. My degree in the numerator here is 2. My degree in the denominator is only 1, which means I'm missing a power in the denominator. Okay, so I'm going to go ahead and add in that extra power. So now we are equal heavy, 2 and 2. The other reason you know this is squared, besides the equal power idea, is because both of these functions are going down to the same direction, so I know I have an even multiplicity. Okay. So now we are equal heavy. My horizontal asymptote should be negative 1. Currently speaking, it is 1 times 1 over 1 times 1, which is just positive 1. And I want it to be negative 1. So what am I going to multiply by? I'm going to multiply by a negative 1. So that negative 1 needs to be in my function. Okay? That's objective 6.